All right, let's start one more exciting session in Azure Administrator. And let me show you the agenda for this particular session. In this, we are basically going to cover about Azure Load Balancer, and we are going to cover two types of load balancer. One is called as, there are two types of load balancer on Azure. One is called as internal load balancer, external load balancer. And we'll configure load balancer. When we are configuring load balancer, we have to configure components called as front end IP address, backend pool, inbound load balancing rules, and health code. These are the mandatory components that we have to configure while we are creating a load balancer. And we'll understand about virtual machine scale set, how to configure a virtual machine scale set. In short, it is called as VMSS. So basically, this is an auto scaling feature on Microsoft Azure, and we will see how to do the configuration of a virtual machine scale set. That's going to be the agenda for today. Now, first of all, let us understand what is a load balancer. Now, load balancer, in short, it refers to evenly distribute load among multiple backend resources or web servers. What do I mean by that? Let me share my whiteboard and let me draw a picture and explain you. Now, I am on my whiteboard. Now, let us say I have a web application. Okay, and I'm hosting my web application on this web server. Let's say this is a web server. Okay, and now this web server, this has an IP address. Let's say the IP address is 192.168.0.1, for example. And on this I hosted a website. Okay, and this is my website code, which is there in this index.html file. Okay, now let's say I'm going to use a DNS service. Okay, Azure DNS. Now in the DNS, we're going to make some entry. The entry will be like 192.168.0.1 is equal to, what is a website name, what is a domain name. Let's say the domain name will be www dot levelupedu.net. That means whenever I go to the web browser and open this web page, okay, with the help of DNS, it will go ahead and open the connect to this web server, and in this web server this page will open up. That is how normally it will work. Now let us say one web server is not enabled for me to manage the traffic. Then what I need to do? Okay, I am going to have two web servers. Now in this web server also, I have my index.html page which has my website code. Now this server is also having an IP address, let's say 192.168.0.1, and this server is also having an IP address 192.168.0.1. Now in the DNS, which server entry I have to make, this one or this one? If I make this server entry, all the requests will go to this server only. Load will be as usual. If I make this server entry, all the requests will go to this server. Now, what I want to do to distribute the load evenly, I want to add another component that is called as load balancer. Now, all the requests from the end users will basically come to this load balancer, and this load balancer is intelligent enough to understand that it has to distribute the traffic to both the servers which is there. First request goes here, next request goes here, next request here, next request here. So it evenly distributes the traffic to both the web servers which are connected at the backend. So now, which is the front end here? So for the user, this is the front end. So I was showing you multiple components, right? So one of the component is, while configuring a load balancer, we have to configure a front end IP address. So for this load balancer, when if I configure a front end IP address, it would come something like this: 192.178.0, let's say dot 4. Okay, now if I configure this as my front end, okay, if the requests are coming to this will distribute the load to the web servers. Now where it will distribute? So I have to create a pool of backend servers. It can be 2, 3, 4, 5. It can be any number of servers I can add to this backend pool. So I have to configure front end pool. I have to configure a backend pool. Now let us say, if for example this server is down. Now if the server is down, should the load balancer send the request to this? It should not send, right? Then how this particular load balancer will come to know if the server is down? For this, we have to configure something called as health probes. Okay, we can define like for how many number of seconds this load balancer keep on checking whether the web server is up or not. All right. So we have to configure front end, we have to configure backend pool, we have to configure health probes. Now we have to add all the rules, front end, back end, and health ropes to basically called as rules. Okay, these are the multiple components which are there. Let me show that again. Okay, we have multiple components. One is front end. Okay, that is load balancer, front end IP address we have to configure. Second one, we have to configure a backend pool. And what is the front end IP? What is the backend pool? All that we have to mention that in a load balancer rules. And we also have to configure a health probe to keep checking whether the web servers are up and running or not. Okay. Now, I told you there are two types of web servers. So two types of load balancer. One is called as internal load balancer. One is called as external load balancer. What is this internal load balancer and external load balancer? Now, if you see on this picture which is there, a load balancer which is open to the public with the help of port 80 is nothing but a external load balancer, or you can also call it as a public load balancer. Now, a load balancer which is internal, that means the load that is balanced between the web tier and a business tier or any logical functions it has to run. Okay, that happens through port number 443. Okay, this is internal. Okay, that means it will not have a public access. This load balancer is between the multiple servers, which is internal. So when we configure a load balancer, we can choose whether this particular load balancer that we are going to create, is it for public or is it for private. That means internal or external. Internal load balancer is balancing between two tiers of an application. Okay, balancing between two tiers of an application, it is called as internal load balancer. Okay, balancing with public, it is called as public load balancer. You see, all the requests will come through public through port 80, and with port 80 it will connect to load is distributed to any one of the servers through port 80. If it is internal load balancer, the port is used for the balancing of load is port 443. That is an internal load balancer and external load balancer. Now, let us go ahead and see a simple hands-on exercise how to configure this. First, we will see an external load balancer which is open for the public. So, what we are going to do? First, we will create, okay, lab. First, we will create a web server, okay, and we'll host a website. Okay, and then we will create load balancer. Okay, and then we will create all this. So while we are creating the load balancer, we will create front end IP address, and then we'll create backend pool, basically all the required components, and then we'll configure rules, and then we'll configure health probe, and then we'll take the front end IP address, put this in web browser. Okay, and see our load balancer is working on it. Okay, so to do this, let me switch to my, after doing this, what we'll do, we'll create one more server, add to the load balancer, and see load is getting balanced or not, load is getting distributed or not. Okay, so we will do this. First of all, let me go ahead and create a simple web server and host a website on that. All right, let me switch to my Azure portal for this. Okay, my Azure portal page is coming up. Okay, go to this option called as virtual missions. Go to virtual missions, go to virtual missions, select option create, go to Azure virtual missions. Okay, now let me choose the configuration. Subscription is pay as you go. Okay, I will create a new resource group. Resource group, I'll name it as delete. Okay, virtual mission name, I'll say it as LB demo 1. Okay, that means one first server for load balancer. Okay, and I will choose Ubuntu server, that is good for me. And let me select 16 GB memory is there. I will take a basic one which has one CPU and 4 GB memory. I will use a public password authentication. Let me give the username and password. Right, let me give the password. Okay, now because I want to make this as a web server, let me open the web ports and then select option review and create. So basically now I am creating a web server. Okay, this is going to take a minute time. Okay, now select option called as create. Now it is doing a validation. Validation has passed. It is initializing the deployment. Okay, it is submitting the deployment. It would take about another 15 to 20 seconds for the deployment to continue. Okay, deployment is in progress. All right, meanwhile, let me go ahead and get the code that I want to put on the website. Let me go to my folders. Okay, let me go to this folder called as JS, and let me open this code. I'll open with Visual Studio Code. Okay, this is the file. Uh, Let me copy this so that I can put this in the HTML page. Copy. Okay, the deployment is still in progress. Let's give it a moment. Okay, it's almost done. Okay, now it is created. Let me go to resource now. Okay, let me connect to this server. Okay, to connect to the server, because it is a Ubuntu server, I need to go to PuTTY. Okay, and I have to give a server IP address. This server IP address, you see, it is 2163.218.96. Let me copy or type in here 20 163.218.96. All right, let me open this and accept, give the username and the password. That is my username, and I'm going to give my password. All right, that's the username and password. I am able to log into the server now. Let me change as a sudo user, sudo su. I'm going to root folder, ls. I can see all the default folders here. Let me update the operating system. If it is Ubuntu, you need to use a syntax called as sudo apt update. So it will update all the Ubuntu OS packages. And then to install, to make this as a web server, we need to install a software called as Apache. To install that, I mean that's package, to install this package, you need to use sudo apt install Apache 2 is the package, version 2 hyphen y. Okay, now the package is getting installed. It's 98% completed. All right, now let me copy this IP address and put that on a browser. The IP address is 20.168.218.96. 2168.218.96. 163.218. 163. All right, let me run this and see whether the web page has come up or not. A default web page has come up. Okay, now I want to put some code there so that our website will come up. To put the website code, let us see now ls. You see there's a folder called as var. Go into the folder slash var ls. You will find a folder like www, which is there here. Go there. Okay, ls. Now you will see a html folder, cd html, and ls. You will see a html index.html file. I want to change this index.html file. Okay, cat. Okay, I'm just putting some dummy code so that all the default website code which is there, it will go. Now I want to put the my code into this index.html file. Enter. I remove this h, copy my code. Okay, I think let me go back here to copy the code. Copy, paste it here. Enter. Okay. Now I have given my own website code. If I see this, okay, it should come. This is the website HTML code that we have given there. Okay, our website is up. Now let us configure load balancer. Connect this server to this particular load balancer. Let me go back here. Uh, in the search bar, type in load balancers. You see these load balancers here. There's an option on the top called as create. Select option create, and I will create in the same resource group called as delete. Name of this load balancer, I will give it as demo load balancer. Okay, and standard SQ is okay. So what is this type of load balancer? Is this public or is it internal? So I'm going to create a public load balancer, and this load balancer should be regional or global. Regional is fine. Let's go to front end IP configuration. As I told you, a couple of components. One of the component is front end IP configuration. Select this, add a front end IP configuration. Okay, give a name to this. I'll say my new IP. Okay, do you want an IPv4 or IPv6? IPv4 is fine. What type of IP address? Okay, whether it should be IP prefix or IP address. I want this to have an IP address. Okay, choose an IP address. The IP address I don't have yet, so let me create one. select option create. I'll give the name as my demo IP. All right. Select option create. Now the system will automatically create an IP address by this name and it allocates one public IP address to this name. Okay. Select option add. So now the front end IP configuration is created. Now let me go to backend pools. Okay. Select an option called as add a backend pool. And in the backend pool, give a name to that. Okay. I'm giving the name as my backend pool. Okay. And the virtual network. Okay, I will select the virtual network as LB demo 1 VNet because this is where our virtual machine that we have created. Okay, so our virtual machine and our load balancer should be part of the same network. Select option add. Okay, now if you see whatever virtual machine is there, which we have configured as a web server, you can see that virtual machine here. Okay, select that and select option add. Okay, now click on save. So till now we have created a we are creating a load balancer. We have given the basic details and then we configured a front end IP configuration and then we configured backend pools. And then we have to configure rules. That means what is the IP configuration, what is the backend pool, what is the health probe, all that we have to mention in the rules. So let me go to inbound rules. Okay, now select this option called as add a load balancing rule. Now my rule name, I'll give it as new rule. Version is IPv46. And what is the front end IP address? We created a my new IP, right? Select that. Okay, backend pool, I have created my backend pool. Select that. And what is the port? In the picture that I've showed you, the port number is 80, right? Select that port. Health probe is 80 and create new health probe. I'll say new health probe. By using what protocol? It has to use a TCP protocol. Every 5 seconds, it has to keep checking whether the servers which are added to the load balancer are they healthy or not. We can change this. We can put it as 10 seconds also. We can put 30 seconds also. So what happens if every 5 seconds, if the load balancer is checking whether the web servers are healthy or not, if any web server, if it is not healthy, load balancer will not send the load to that particular server. Okay, select option OK and then add. All right. So we have configured I front end IP configuration, backend rules, and inbound rules. If it is an internal load balancer, we also have to configure outbound rules, but as of now, we can leave it as it is. Select option tags, review, and create. Select option. It is running a final validation to check whether all the configuration that we have given is it qualified or not. All right, now let me go ahead and select this option, create again. This would take about a minute or a two for the load balancer to be created, because while the load balancer is creating, it will also create that front end IP configuration, and then it will allocate an IP address, and then it's going to create a backend pool and add the web server that we created to the backend pool. Once it adds the backend pool, it will create the rules and it will create a logical container, and it will put the front end IP, backend web server, and the rules all in one container so that our load balancer can work. Okay, this would take about another 30 seconds. Let's wait for that. If you see a resource is created, let's go to the resource. Now very simply, if I go to the front end configuration, okay, you see this is the IP address. Let me copy this IP address and put that on a web browser. I should be able to see the web page. You see, I'm able to see the web page. That means what is happening. Let me go back to my whiteboard. Okay, what we did in this hands-on exercise. we created this load balancer. While I'm creating this load balancer, I created a backend pool with the virtual machine. Now, as a user, I'm hitting this load balancer. Now, in the browser, I have put the IP address of this load balancer, not the virtual machine. So when I put the IP address of this virtual machine, it is going ahead and communicating with this. Now, if I hit one more time, one more request to this load balancer, I want that to go to another virtual machine, but we did not add another virtual machine to the pool, right? Now, what I will do, I will create another virtual machine. I will add that virtual machine to this pool. And what I'll do this time, I will change my website code so that when I hit first time, it should go here. I will see the web page which is there here. Second time when I hit, it should show me the web page here. So that means I can see very clearly load balancer is distributing load between this server and this server. Ideally, we will not have two web pages. Ideally, we will have only one web page in both the servers. Load balancer will distribute the load. But for us to understand that the load balancer is distributing the load, whatever web page that I have put here, I'm going to put a different web page on a second web server. So that if I keep on hitting the load balancer, it should take me to this page, and then next it has to take me to this particular page. Okay. So for that, let us create another web server and create a new web page on that. Let me go here. Okay, now this web page is working, right? So this web page is working. This is up and running. Now let me go to virtual machines again. Go to virtual machines. Let me create another virtual machine. Okay, now this virtual machine name, I will give it as, let me put that in the same resource group. Okay, the virtual machine name, I'll give it as LB demo 2. Okay, rest all I would like to leave as it is. Okay, and I'll change the username and password. I'll use it a password. Username is this. Okay, and let me make it as a web server. So I need to open the HTTP and HTTP ports. Select option review and create. Let the server get created. Select the option create. Meanwhile, let me go to my HTML code and then change the code a little bit. Okay, where there's a DevOps classes, I'll put it as okay. I just changed code little bit so that it'll be easy for us to understand. Let me copy this code now. Okay, I copied this code. Let the server get created. Okay, now let us go to resource. Let me log into this. Let me go to putty. I'll select open new session and let me put the IP address here. It is 172.173.159.242. Let me connect to this and my password. enter. Right, let me go to as root user, root folder. Let me directly change the code in my index.html file. Oh, let me update. Okay, I'm running an update, and then I will install Apache package. Okay, now Apache is getting installed. Right, let me go here slash. I'm giving the complete path. Let me use a VI to edit the file. Think I have to give this path. Okay, I want to create at this path, right? Give this VI and this. Okay. Now let me copy my code here. Okay. Now let's see this web page, what it is showing us for us. Let me put that in a new tab. It'll be 172 dot. Okay, you see Azure classes. Now if I go here, DevOps classes, you see this is the IP address of the load balancer, and this is the IP address of a individual server. Now what I will connect this server also to the load balancer, and when I hit this first time I'm getting this, second time if I hit I should get this Azure classes. Okay, let us see that. Let me go to the load balancer again. Okay, demo LB is the load balancer. If you see here backend pools, let me go to the backend pools here. Go to the backend pool, select option add. You see now we can also see something called as LB demo 2. Okay, this is a new server. I'm adding this also to this load balancer. Select option same. Because we already have created load balancer every component, there is nothing else for us to do. I'm just adding the server in the backend pool. After some time, if we want to add another server, we can just create the server, add to the backend pool. That means that particular server is part of the that load balancer. Okay, what I have done here, first I have created load balancer. I have added one virtual machine to the backend. Now I created this load balancer and added to the backend pool. Okay, sorry, let me rephrase that again. So now I created a load balancer. I created a backend pool. In the backend pool, first I have added only one server. And now I created another server and added that also to the backend. Okay. Now let us see whether now if I try to access this load balancer now, my request has to go here. If I give another request, now it has to go here. Now because I have two web pages here, first it has to show me whatever web page is there in this particular server. Second is it has to show me whatever web page in this particular server. Okay, let us go ahead and hit that web load balancer and check. Now you see both the servers are there. Now this is our web page, right, which is showing DevOps classes. You see now, after if I hit, the same thing is showing Azure classes. Now let me hit that again. You see it is showing DevOps classes. That means we can clearly see that it is distributing the load between multiple load balances. Okay. Now let me, because it is there in the buffer, it's not showing that again. Wait for a moment. Again, it will shows the web page which is there in the second server. Okay, let me copy this and put that on a new web browser. You see, now I got Azure classes. So that means this load balancer is balancing the load between multiple servers. Okay. Now, if I want, we can add one more server. See, ideally for us to see that load is getting distributed, we added different pages here. But ideally, it will be same page here as well. Okay. That is about load balancer. Now, there is next feature called as auto scaling. Now, what is this auto scaling? Now, let us say, okay, now let us say I have a load balancer here. Okay, to the load balancer, we have added one web server. This is a second web server. Okay. Now, this server is capable of, let's say, 100 users at a time. This is like capable of 100 users at a time. Now, I'm getting like about 400 requests. Now, do I have to, what is the option for us? We have to create server and add that server to the load balancer, right? But Azure gives you an option called as um, auto scaling. Okay, with this feature called as VMSS, which is called as virtual mission scale set. With the help of this feature, what happens is that whatever virtual mission that we have to add, it will automatically add by itself. So we can say, let's say if the CPU is like about 70% utilized, let's add a new virtual machine. A new virtual machine will be automatically created and it will add to this. Okay. Now, if the load is more, again it will add. If the load is more, again it will add. So at the peak times, virtual machines will automatically get added to this particular load balance. But what if the load is reduced? If the load is reduced, this feature will automatically remove the virtual machines to this. So in this scenario, what happens whenever I require servers to take the load from my application, servers will automatically create and get attached to the load balancer. Whenever I don't need them, when the performance of the servers are less, it will automatically remove them. So this virtual machine scale set lets us to create and manage a group of load balanced virtual machines. The number of virtual machines can automatically increase or decrease when there is a demand, or it can also be a defined schedule. Let's say evening 4 to 6 o'clock, let 10 virtual machines can create automatically. Okay. So with the help of this, it is easy to create and manage virtual machines. It provides high availability, and it lets our application automatically scale and give resources or give virtual machines when it requires. Okay, it works at a very large scale. Okay, and it is very flexible. That is basically a very beautiful feature, because whenever your application requires, it has the virtual machines. When you don't want it, it is removed. Okay, that is called as virtual machine scale set. Now let us see how to create a virtual machine scale set. Let me flip to my Azure console. Okay, now I'm on my Azure console. To work with virtual machine scale set, let me type in VMSS. Okay, you see there's an option called as virtual machine scale sets has come up. Let me click on that. Select option create. Okay, uh, create a virtual machine scale set. I will select the same resource group as delete. Okay, give a name to the virtual machine scale set. The name I'm going to give as auto scale random name. Okay, now if you want we can select the availability zone where it has to be there, so you will get high redundancy. Orchestration flexible or uniform, flexible is enough. Security type, if you want to have uh, high security, you can select your security types. Standard or trusted virtual machines, standard is fine. Image ubuntu is fine. And if you want to run a spot instance where you will get a discount, we can select run with a spot instance. As of now I don't want to choose that. All right, this configuration is enough for me. And let's go to password, give a username. Okay, I have given my username and password. Now you select the type of instance. All right, I don't want a spot instance, so we can go to the next option, disks. If you want to add any additional disk, we can create an additional disk and attach. I don't want that. Let's go to networking. Now here default network is okay for me. Okay, and you see here there are multiple options. What is a load balancer? I want to select a load balancer this missions has to create and attach to, right? Okay, now select the option Azure load balancer. Now it is showing the load balancer which I already have. The load balancer name is demo lb. Okay, uh, okay, now if you see, this load balancer is there in a different network, different virtual network, and this particular is there in a network called as delete underscore vnet. Okay, this is there in a different network. So let us create a new load balancer. I'll say for VMSS. Okay, and this should be public, all fine. Select option. See the port number 80, backend port, everything it is selecting by itself. Load balancer rule, everything it is selected. And whatever servers are going to be created, it will automatically add to the backend pool. Okay, this load balancer is created. Now scaling. Now, initially it has to start with how many instances? Let's say initially, I'm saying that initially it has to start with 3 instances. What is the scaling policy? That means when a new instance has to be created, I can choose whether it can be manual or auto scaling. If it is auto scaling, you say minimum number of instances, maximum number of instances. Let's say I'll put minimum 3, maximum let's say 100. That means it will keep on increasing 100 servers if this rule satisfies. What is the rule? I can say scale based on CPU matrix. If the CPU is 50% occupied, I want a new system to be created. And when it has to see for 10 minutes, constantly for 10 minutes, CPU should be 50% busy. Then only it has to do what? It has to create a new instance. How many it has to create? One. Okay, now when I want to reduce that, let's say if the CPU utilization is less than 50 minutes, sorry, less than 50%, I want that to reduce by, okay, it should be smaller than the threshold. Let's say if the CPU's utilization is less than 40%, decrease by one server. Okay, that is the rules that I'm applying. But if I want, we can also configure a rule based on a schedule, like on Tuesday, on Wednesday, okay, on this timing, I want the instances to be created. Okay, so in that way also we can do that. But as of now, I want to create scaled on the matrix. Minimum number of instances that we require is 3. Next, go to management. Okay, we can leave everything for defaults here. Health probe is fine. Everything is configured. Let us go ahead, review and create. Now basically with this we have created a load balancer we have created all the backend pools, etc., etc., and we are creating virtual machines and adding the virtual machines to this particular pool. Now, if you see in this load balancer, will three virtual machines will automatically create and add to that particular virtual machines. Now, if these virtual machines, if they are getting heavy load in the sense what we configured 50%, right? For 10 minutes, if the CPU is 50% utilized, it will automatically create another instance. The maximum it will go up to is 100 instances. Okay, the deployment is in progress. Let's wait for a moment. This will take another moment. Now let's go to the resource. Now I have given the name as this, right? Now if I go into this, okay, let's go into the load balancer because we have created a second load balancer, right? Let's go to this load balancer. Okay, the load balancer name is for VMSS. If I look into the backend pools now, you see there are three servers. This is B pool 3 because we have told minimum instances 3, right? So it automatically created 3 instances. Now, if we host any application on this, if the CPUs are 50% busy, it will automatically create another server. If it is busy, it will create another server. So like that, max it will go up to 100. And if the CPU utilization is less than 40%, it will automatically delete the virtual machines. So that is how using VMSS, that is virtual machine scale set, resources can be automatically scaled or scale reduced, I mean scale out, scale in. That means either increase or decreased based on the load. All right. That is how you create that. Let us see what we have learned today. Okay, this is what we have learned today. So we understood what is an Azure load balancer. We configured an internal load balancer. While we are configuring, we understood these components. What is a front-end IP address? What is a backend pool? How to configure inbound load balancer. We also understood about health. And we also configured auto scaling by using VMSS on Microsoft Azure. All right, this is what we have learned today. I suggest you guys to do the hands-on exercise, then it will be clear for you people. All right, see you guys in the next session. Take care.